In this video we are going to talk about binary tree, its properties and its types, right. In the previous video we have discussed what is a tree and you can say that introductory part of trees, right. Some basic terminologies which are used in tree as well as how to represent a tree, the logical representation of a tree, right. The basics we have discussed. Now we will discuss the binary tree. See, now first of all, what is a binary tree? See, it is a tree in which each node can have maximum 2 children, or you can say at most 2 children, fine. Each node, see, as the name suggests, binary means what? 2, I mean 0 and 1. So you can say in which a tree in which each node can have at most 2 children, at most 2 means each node can have either 0, 1 or 2 children, but cannot have more than 2 children, right. That is a binary tree. Now how to represent a binary tree? See, if I draw something like this, is this a binary tree? Yes. See, these are nodes, this thing we have discussed already. Now this is having, this node is having 2 children, fine, and these are having 0 child, so that is also fine, this is a binary tree. Now is this a binary tree? Yes, this is also a binary tree. This is having only one node, that is root node, having no children. That is possible, we can have 0 child, a node can have 0 child, right. So this is also a binary tree. Now see, what about this one? Is this a binary tree? Yes, this is also a binary tree. See, here each node is having, this node is having one child and one child, this is having 0 child, that is also possible. Now see, is this a binary tree? This is not a binary tree, because see, here in this case this node is having 3 children, that is not possible, we can have at most 2 children, so this is not a binary tree, right. All these are binary trees. This is also a binary tree, right. Now if I draw something like this and this is also a binary tree. The only condition is what? Each node must have at most 2 children. If this condition satisfies, that is a binary tree. Now how we are going to represent this binary tree in memory, that thing we have already discussed in the previous video. See, here this is the node, each node is having what? Information plus may or may contain links. That is not compulsory that each node should contain link to another node. Maybe if node does not have any child, then it will not contain any link, right. So how you are going to represent this binary tree? See, this is a node, first node is something like this, 3 parts would be there. This is what? Left child, this is what? Right child, you can say. So here we have the data part, you can say here I am storing 1, this is what left, this is what link to the right child. So here we have one node, this node is suppose having data 2. Now see, this node is having only left child, so this is having only this link is null, right. So now here this is also suppose containing 3 value, 1, 2 and 3. Here I have 4, 5 and 6, because these node are having some information stored there. 3 is not having any child node, so there is no this link and this link would be null. This is how we are going to represent this one. Here in this side we have 4 is having both left and right child, so this is left and this would be right. Here we can have 5 and here we have 5 and 6. Both 5 and 6 are having no children, so the links would be null, right. This is how we are going to represent the tree. Actually, this is just a logical representation of a tree. How we are going to store the tree in memory? We are going to dynamically create these nodes, we are going to set these links, that thing also we will discuss, the implementation of binary tree, right. Now next thing is, see now some properties of binary tree. See, we have discussed what is a level in the previous video. This is node, this is what? Level 0, this is what? Level 1, this is what? Level 2. Now at any level, see, at suppose I am taking at level 1, how many maximum nodes can be possible? See, at level 1 only 2 nodes can be possible, maximum nodes. Here we cannot have 3 nodes because at most 2 children can be there. Now at level 0 the maximum node possible is only 1, right. At level 2 the maximum node possible are, see the maximum node can be, here I have 2, here also I have 2 and 2 children of this node. So this is what level 2. At level 2 we can have 4 children maximum, we cannot have 5, 6 or something like this, right? This thing I guess you are getting my point. Now suppose I am increasing one level, at this level, at third level, the maximum number of children possible are, maximum means each of this node is having maximum children, and maximum children can be 2 only. It means 1, 2, 3, 4, 5, 6, 7, 8, right? So here 8 can be possible, here 4 maximum, here 2, here we can have 0. Simply same, if I increase one level more, then here at this level how many maximum number of nodes are possible? You can say each this node at level 3, each node will have 2 children. So here I have 8 nodes, so 8 into 2, that is 16 can be possible. So at level 4, 16 maximum node can be possible, right? Now how you can write this thing? Can I write here 2 raised to power 0? Can I write 2 raised to power 1, 2 raised to power 2, 2 raised to power 3 and 2 raised to power 4? So now what you can say here, at each level I, the maximum number of node possible in a binary tree is 2 raised to power I. That is one property, right? The maximum number of nodes possible at any level I is 2 raised to power I, right? This thing I have already shown you. Now next point may be the maximum number of nodes possible at height h, the maximum number of nodes of a binary tree, right, at height h. See, at this level, suppose I have 3 levels only. Now height of this tree is what? Height of the root node is equal to height of the tree. Height of root node is what? 1, 2 and 3. Go to the longest path, find out the longest path from the root, or you can say from that node to the leaf node. So now here height is 3 only, right? Now at height 3, maximum number of nodes possible are, see how to calculate, you are supposed to add all these nodes, means you are supposed to add first of all 0 plus at this level I have 2 plus at this level I have 4 plus at this level I have 8. It means you can say 40 number of nodes, right? Maximum number of nodes, fine. Now if I say height is only 2, right? Height is 2 means I am removing this level, means now height is 1 and 2, height of root is 2, so height of tree is also 2. Now if height is 2, maximum number of nodes possible are 1, 2, 3, 4, 5, 6, 7. So how to calculate maximum number of nodes? If height is h, simply you will add all the maximum number of nodes at each level. So you can say 2 raised to power 0 at this level, 2 raised to power 1 plus 2 raised to power 2 plus 2 raised to power 3 and till 2 raised to power h. Now this is what simply a GP series, and how to find out the sum you can easily Google it out. I am not going to tell you this thing. So answer of this would be 2 raised to power h plus 1 minus 1, right? So maximum number of nodes of height h, I am talking about this binary tree, right? So maximum number of nodes can be h plus 1 minus 1, right? And if I ask you the minimum number of nodes, if height is h, then see, minimum number of nodes can be h plus 1. How? If height is this one 0, it means height is 0 means we have only one node, right? We don't have this thing, we have only one node, it means height is 0. So the minimum number of node is 1. If height is 1, see, this is height 0, this is a tree, binary tree having height 0, minimum number of node is 1. Now if height is 1, I am going to increase the height. Now height is 1, height of this tree is what? 1. Minimum number of nodes are 1 and 2 only, minimum number of nodes. I am not adding this node, second node, right? Now if you increase the height one more, suppose I am increasing height one more, now height is 1 and 2. Now height is 2 and minimum number of nodes are 1, 2 and 3. If you will increase one more height, now height is 1, 2 and 3. Height is 3, minimum number of nodes possible are 1, 2, 3 and 4. So you can say minimum number of nodes possible are h plus 1, h plus 1, h plus 1, 3 plus 1 is 4. If height is 1 means this one height, 1, 2, two nodes are possible, means h plus 1, minimum number of nodes are possible, right. Next thing is, if suppose you are given maximum node, minimum nodes, and you are supposed to calculate the height, you can say the maximum height of the tree possible and minimum height of the tree possible, then how you will calculate this thing. Now suppose you are given there can be n maximum nodes in the binary tree. Now you have to find out the possible height. So maximum number of nodes are n. As from this case we can say the maximum number of nodes can be of height h can be 2 raised to power h plus 1 minus 1. Here you are supposed to calculate h value, means here I am calculating height of the tree. Now how you will calculate n plus 1 is equal to 2 raised to power h plus 1. I guess you can easily solve this thing by taking log on both sides. Log of n plus 1 and log of, see base is 2 raised to power h plus 1. Now this thing is what? Log 2 n plus 1, log 2 base 2 is this one and this one is also 2. So here simply we can write h plus 1, right. Now here height you are supposed to calculate, height is equal to log 2 n plus 1 minus 1, and here we are taking the ceiling function. So this can be the height, right, but this can be the minimum height. If maximum nodes are given, those nodes can find out, using those nodes you can find out the minimum height. If minimum number of nodes are given, that will give you the maximum height, right. Now suppose minimum number of nodes are given n, right, n. Now height is what? Now minimum number of nodes of height h, we know h plus 1 can be there. Now simply calculate the height is equal to n minus 1. So this can be n minus 1 can be what? Maximum height n minus 1, and minimum height can be this one, log 2 n plus 1 minus 1. Now we will see types of binary tree. So types are full binary tree, this is also known as proper or strict binary tree, complete binary tree, perfect binary tree, degenerate tree, and balanced tree also. But balanced tree we will discuss when we will discuss the ABL trees, right. That is also that is basically known as balanced tree. Now what is full or strict or proper binary tree? See, the definition is what? It is a binary tree where each node contains either 0 or 2 children, or in another term you can say it is a binary tree. See, of course, obviously it is a binary tree, plus one more condition is it is each node is containing either 0 or 2 children, or you can say each node will contain exactly 2 children except leaf node, right. Now see, what is a full binary tree? Now if I draw something like this, is it a full binary tree? Yes, because it is a first of all a binary tree, plus here each node is containing either 0, see this one is containing 0, 0 and 0, means these are leaf node, right, or 2 children, this is containing 2 children, this is having 2 children. So this is what a full binary tree. Now see, this is what? Is this a full binary tree? No, this is not. Why so? Because this node is having only one child, but that is not possible in full binary tree. Now see, this is what? Is this a full binary tree? Yes, this is a full binary tree, right. Now see, is this a full binary tree? Yes, it is a full binary tree. Is this a full binary tree? No. But is this a full binary tree? Yes. Each node is containing either 0 or 2 children, or all the nodes are containing, each node will contain exactly 2 children except leaf nodes, right. Now same, the property of this full binary tree is what? Here number of leaf node is equal to number of internal nodes plus 1. Here you can say this is a full binary tree. Now here number of leaf node, count 1, 2, 3, 4, 5 and 6, number of leaf node are 6, right. It should be equal to number of internal node plus 1, means here number of internal node should be 5, 1, 2, 3, 4 and 5. I have discussed what is leaf node, what is internal node in the previous video, you can check out that video if you don't know. Now what about maximum node and minimum node in this tree? See, maximum node is same as binary tree, right? Because here also at this level, at this level, at this level means at every level I, there can be 2 raised to power I maximum nodes. And if height is at h, then you need to add all the maximum number of nodes at each level. So this is 2 raised to power h plus 1 minus 1. This thing we have already discussed, right? Now what about minimum nodes? See, the minimum number of nodes. Height is 0, so minimum number of node can be 1. If I am increasing height 1, this is height 1, so minimum number of node can be, see, this is not a full binary tree, we need a full binary tree, so here you need one more node. So 3 can be the minimum number of nodes. Now if you increase height one more time, that is, now height is 1 and 2, height of this tree is 2, but this is not a full binary tree, you need to find out, you need to satisfy that condition also. Each node is having either 0 or 2 children, so this should contain 2 children. This can have 0 children because you are calculating minimum number of nodes. So 1, 2, 3, 4, 5, right? If height is 3, I am increasing one more height, 1, 2 and 3. Here also you need 2 nodes. So minimum number of nodes can be plus 2, that is 5 plus 2 is C. So now how you can write down this thing? C, 2 raised to power h plus 1, minimum number of nodes. Now how to calculate minimum height and maximum height? See, the maximum nodes will give you minimum height. This one, minimum height. So minimum height would be same as previous one, as binary tree. N plus 1, here ceiling minus 1, right? Because maximum node are same. But here the maximum height can be, the minimum nodes are 2 raised to power 2 into h plus 1. So how to calculate? If minimum number of nodes are given n, how to calculate height? 2h plus 1. H is equal to n minus 1 divided by 2. So here you will write n minus 1 divided by 2. Now next is complete binary tree. So now according to the definition of a complete binary tree, see, a binary tree is a complete binary tree if all the levels are completely filled, except possibly the last level, fine. Plus at the last level we have one more condition, see, and the last level has the nodes as left as possible, right? We are going to fill the last level from left to right. See, now I am going to take one example. See here, this is the last level, right? And this is not completely filled because these nodes are not having any child. So that is fine in complete binary tree. See, we have told you, I have told you, except the possibly the last level, all the levels are completely filled. See now, this level, this level, this level, this is what completely filled, right? Each node is having 2 child. So one condition is true. Now second condition is complete binary tree is what? In the last level, the nodes should be as left as possible. Means we are going to fill the nodes in the last level from left to right. You cannot leave these nodes free, these spaces free, and you cannot write here the child node, right? So you need to delete, and if I shift here, then this is what a complete binary tree. Now is this a complete binary tree? No. Why so? Obviously, see, except the last level all the nodes are completely filled, but second condition is what? Here the nodes should be as left as possible. We have left this node blank and we have put children to this node. That is not true in complete binary tree. If this is also having 2 child, then this is fine, right? Now is this a complete binary tree? Yes, because here the condition is not that each node is going to have exactly 2 children. So at the last level you can have 1 child, but that should be filled from left to right. See, here if you write this thing, you cannot fill the right child. First of all, you will have to fill the left child, right? So now this is also a complete binary tree, right? And this is also a complete binary tree. Now see, is this a complete binary tree? No, this is not, because now this is the last level, right? So at the last level you can fill the node from left only. So here you should fill the left child, you cannot fill first of all the right child. Is this the complete binary tree? Yes, this is a complete binary tree, right? Somewhere it is also written as it is nearly complete binary tree. Fine. Now, in this case also same. What about maximum node and minimum nodes? Maximum node, obviously this is a binary tree, so maximum node are same, that is 2 raised to power h plus 1 minus 1. Maximum node in a complete binary tree of height h, right? Now what about minimum number of nodes? Here the minimum number of nodes are 2 raised to power h. This thing you need to find out how the minimum number of nodes are 2 raised to power h. I am not going to trace out this thing. Now minimum height and maximum height, obviously minimum height would be same as the previous one because maximum nodes are same in all the 3 binary trees, right? Now what is maximum height? Maximum height means minimum nodes will return you the maximum height. So how you will calculate? I am going to write down this thing, you need to calculate this thing, right? So the maximum height in a complete binary tree is log n. This thing you need to calculate how this is 2 raised to power h and how this is log n, right? So this is what a complete binary tree. Now perfect binary tree. See, a tree can be a perfect binary tree if all the internal nodes are having 2 children and all the leaf nodes are at same level, right? These 2 conditions. Fine. Now see, I am drawing one tree. All the internal nodes should contain exactly 2 children. So here these are leaf nodes, but all the internal nodes are containing how many? 2 children, right? But second condition is what? All the leaf node, all the leaves should be at same level. But here see, this is what level 0, 1, 2 and this is what? 3. So 2 leaf node are at level 2, 2 leaf node are at level 3. So this is not a perfect binary tree. All the leaf nodes should be at level 3. So now how to do this thing? Now see, these are leaf node and all the leaf node are at level 3 and all the internal nodes are having 2 children. So this is now a perfect binary tree. Now see, this is also a complete binary tree. Can we say it is a full binary tree? Yes, it is also a full binary tree. So every perfect binary tree can be complete binary tree and full binary tree. But vice versa is not true. See, if a tree is complete binary tree, then it is not necessary that it is perfect binary tree. If a tree is full binary tree, then it is not necessary that it should be perfect binary tree, right? Now see, what is degenerate binary tree? Here in this case, all the internal nodes are having only one child. That is known as degenerate tree. So see, this, if you draw this thing, here this is leaf node and 1, 2, 3, 3 are internal node and each internal node is having only one child. So this is what? A degenerate tree. And you can say this is what? A left skewed binary tree. Left skewed binary tree means if the internal node is containing only the left child, then it is also known as left skewed binary tree. See now this tree, this is what? This is also degenerate tree because each internal node is having only one child, that is right child. So it is also known as right skewed binary tree, right? Now taking example of this, is this a degenerate tree? Yes, because see, each internal node is having only one child. This is having right child, this is having left child, right? So this is also a degenerate tree. We cannot say that it is left or right skewed. It is mixture of both. Fine. So I guess this is all about binary tree plus properties of binary tree we have discussed and types of binary tree, right? Now in detail how to implement a binary tree, that thing we are going to discuss in next video. So I'll see you in the next video. Till then, bye bye, take care.